Yeah, I'll just repeat the part I did. So this question is about, we are going to discuss this question from the last HackerRank contest. This question is about finding unique paths through a maze. So in this maze, there's a starting point and the ending point. The starting point is the top left corner and the ending point is bottom right corner. So this traveler can't go through these blocked stones. And there's another condition, this traveler can move in right direction and also down direction. The traveler can't go to left or up direction. So I was explaining this first example. So we know these blocked stones and the starting point and the destination. So this is one path this traveler can follow to reach the destination. And let's see another path can go like this and like this, and reach the destination. Yeah, this is a valid path because we only go to right and down. So we can't go like this and go back and come back. That's not a valid path. So these are two unique paths. We can go from this side, and similarly we can go like this and also like this. Okay. Yeah. So there are 4 paths. So in the output also we can see there are 4 paths. And similarly, so this input is for 2 by 2 grid, and 0 means there are no blocked stones. There are no cursed stones. That means it's a maze like this part. And here there are no blocked stones, so only possible paths are can go like this, here to here or here to here. So there are 2 unique paths. So the answer is 2. So it's a in example 3 is also like it's the same thing like this, and there's a cursed stone in the middle. Starting point to end point. This is one unique path. This is the other unique path. So there are also only two unique paths. So the output is 2. I hope you can remember the dynamic programming basics we did in the last week. So we can answer this question by using dynamic programming. So for an example, I'll retake the this 4x4 grid example I explained first. So in this one, the block stones were this stone and this one. So these were blocked. And as the output, what we wanted to find was a number of unique paths we can take to come to this top bottom right corner. So I'll write it here. So the answer you want is number of unique. So the answer you want is this number of unique paths we can follow to come to this point, this block. So here we can identify that the number of unique paths to come to this block is equal to number of unique paths we can come to this point plus number of unique paths we can follow to come to this point. Because if the traveler somehow comes to this point, that means the traveler came through this path or this path. So the traveler should definitely pass this this block and this block, one of these blocks. So let's say the answer we want is the number of unique paths to come to this block. Let's call it as dp3 3. So this is 3. The coordinates of the square is 3 3. So the let's say this is the name we use for our answer. So similarly, we can call this the number of ways to come to this square is dp 2 3. Similarly, this one is dp 3 2. Okay. So the number of ways to come to this point is equal to number of ways to come to this point plus number of ways we can use to come to this point. So we can identify that dp 3 3 is equal to dp 2 3 plus dp 3 2. Similarly, number of ways to come to this point is equal to number of unique paths to this one plus number of unique paths to this block. So according to this method, if we want to find the answer for this one, we need to find the answer for this one and this one. So if we want to find the answer for this one, we have to find the answer for this one and this one. Similarly, it goes from this point to the starting point. So that's how we can divide this problem into small problems. So I can say that let's start from the beginning. So the traveler is already here because it's a starting point. So there's only one way to come to this point. And if we consider this square, the only path the traveler can take to come to this square is from here to here. So here also there's only one way to come to here. Similarly, here also only one way to come here. Here also same. And when it comes to here, we can say that the traveler can either come from the top square or from the left square. But here, the left square is a blocked square. And we know that the traveler cannot come to this square. So that means we can say here 0. 0 means there's no way to come to, no unique paths to come to this square. So in this one, we can say that the answer for this square is this answer plus this answer. So that means it's also equal to 1. That basically means the number of unique paths we can follow to come to this place is only 1. And when it comes to this one, the traveler can come from here to here or here to here. So the number of unique paths to come to here is this value plus this value. So here the answer is 2. So likewise, we can calculate these values from the top left corner to the bottom right corner. And the answer we get for the bottom right corner is the answer for this question. So now let's see how we can code this. Let me share the, let's go to the HackerRank platform. So we are going to use Python for this answer. So first we need to get the inputs. So there are first there's an input line with the dimensions of the grid. So for that we can say in m equals we can use the map function to read and convert this input into ints. So this line means we are going to read the input from the first line, and we are going to split the input values from these spaces, because these are space separated, and we are going to convert it into integers using map function, and then we can assign these values to n and m, because there are only two values. We know that these values are n and m. Okay, then after that there's another input called the number of cursed stones. We can say that it's c. C means input. We can convert it to int also. And after that, we know that for an example here, the cursed stones is 2. So we know there are 2 lines after this line. So we need to get coordinates of all cursed stones. To save these cursed stone coordinates, let's create a variable, an array called cursed. And also now we are going to run a loop to get the remaining inputs. And we are going to run the we are going to read C number of lines. We are going to read X and Y of these lines. We are going to read the same input in the same format, X and Y. And then we can append these results into the cursed array. We can append it as a tuple. Okay, after that, now we have read all the inputs. So now we have to find the answer. So I said that earlier in the drawing, I showed that we have to find the values for each square in the grid because we are going to use dynamic programming. So let's make an array called dp. So here we need objects for each square of the grid. So here we can write 0, 4, 3, and change 4, and gem. And then so this will make a 2D array for each which will have all the squares in the grid. Then give me a second. Then we need to loop through each square of this grid. For an example, we start from the starting point. We have to find the we have to calculate the value of this square and this square. Likewise, we have to calculate values of all these squares. So what we can do is we can run a loop. So I in range 0 to m means going through each row, and for j in 0 to n, and then so if the current square is a blocked square, that means if it is a cursed stone, the number of unique parts you can use to come to that place is 0, because that cell is blocked. So if this ij square is in cursed, that means we are checking whether this square is in this cursed array. So if it is in this cursed array, that means the cell is blocked. So what we can do is the answer for that cell is 0. Yeah. So that means, yeah, if this stone is blocked, there's no way to come to this block. So otherwise, we are going to we have to find the answer for the current square. So what we can do here is, let's say the answer for this, the current square will be dp ij will be equal to dp I minus dp I j minus 1 plus dp I minus 1 j. That means the answers of top square and the left square. Yeah, the addition of this will be the answer of the current square. So in this, if you use this one, there might be an issue when we are working with these top squares or the bottom square or the left squares, because in this, if we consider this square, there's no square in the top. If you consider this one, there's no square in the left. So this way it might throw an error. So to solve that question, we are going to add some other conditions. So if instead of using this else, now we can use elif I is bigger than 0 and j is bigger than 0. That means this is not a corner stone. Then we can directly use this one. Otherwise, if only I is bigger than 0, that means j is 0, what we can do is we can directly get the answer from the left square. That means dpi j equals dp I minus 1 j. This is a situation like this square. I hope you can see the cursor, right? So in this one, we can get the answer only from the left square, because there's no square in the top. Then there's another condition, which is if the square is in the left side. If j is bigger than 0, that means I is not bigger than 0. Here we can also say that j equals 0, but since we are using these elif conditions, this is using this is like redundant, so we'll just keep only this. In here dp I j will be equal to dp I j minus 1. So so that's the for loop. So after that, after we run this for loop, then all the values for all the squares will be calculated, and at last what we have to do is just print the answer. Print dp I not I m minus 1 n minus 1. That means if there are like if it is 4 by 4 square, the starting index is 0 and the ending index will be 3, not 4. So what we want is m minus 1 and n minus 1. And let's try running this code. Okay, let's see. It fails to give the answer. Let's see what's the error. N and n. So we can debug this, like we can just print these answers just to check whether it's working. Here we are our output 4, means the inputs are correct. Let's try printing the cursed stones. We use this one. Cursed stones are also with we got the correct inputs. What else we can do? So here it's correct, and okay, we forgot one condition. So here what we have to do is the square might be the starting point because we missed the starting point. If I equals 0 and j equals 0, the answer is 1 because this is the starting point. The number of ways to come to the starting point is 1. And then let's see. Okay, we forgot to delete this one. Okay, so the answers are correct. We can try submitting this. Yeah, it's failing for some reason. Let's check it again. Okay, wait. I have a copy of the answer. There might be a small issue here. Anyway, like this one. Yeah, still it's failing for some reason. Let's try a different one. Yeah, now it's working. I think there might be a typing issue in here. So in this answer, we have used a similar method to get the inputs. Here also different. And the answer is almost same. Yeah, I think you got a basic idea about solving this question. And you can also like try these questions even after the HackerRank contest, because these questions are open. So you can submit, but your marks won't be added to the leaderboard. Since we are running out of time, yeah, I won't be able to discuss another question. So I think the HackerRank question is HackerRank contest already started. Yeah, it's already started. So you can try this out. I'll post the HackerRank contest link, and make sure you submit this Google form, because we need your HackerRank username and the name to put in the leaderboard. So I'll just share the form also. Fill this form before you start the HackerRank contest. Yeah, I think we can wind up the discussion session. So yeah, good luck for this week's HackerRank contest. You can start it now. We won't be having a discussion again today. The answers for the answer for today's contest will be discussed in the next week. So yeah, I think we can wind up the session. Yeah, thanks for joining. Yeah, good luck. You can try out the HackerRank contest. Again, make sure that you fill the feedback form. Yeah, Rusi had asked the question. Yeah, you can join the contest, but I think we won't be able to add you in the leaderboard. It's totally fine to participate. Yeah, thank you everyone. We are ending this session. Yeah, good luck.